Let's graph some exponential functions. Why not? So we're going to have some exponential growth or decay. Now this is an example of an exponential growth graph. You'll see it swoops up as it goes to the right. There's exponential decay that would start high and swoop low. There's also all kinds of transformations, some shifts, some reflections. Ooh, it's in for a real treat. So if you look, it's like y equals a times b to the x. Okay, so if the number with the exponent, the b, is greater than 1, it's going to be exponential growth. If the number with the exponent is between 0 and 1, that's going to be exponential decay. It's going to drop down. The number out in front, which is the a, that's going to be your y-intercept. And then we have to kind of pick some other values to substitute in for x in order to get the other points. Now you can pick any numbers you want. I'd pretty much always recommend picking -2, -1, 0, 1, and 2. If there's a fraction, you might want to change those, but those will work every time, and you could just type them into your calculator and it gives you the answer. Domain, that's your input. Those are your x values, and you choose them, but they can always be anything. You could put in anything for x. The range is your y, and you'll see that these hit like a limit at 0. But it'll never actually touch 0. So that line that it approaches is called the asymptote. If you see here, boop, the x-axis is the asymptote. So it'll get closer and closer. It'll look like it's touching it, but technically if you zoomed in, it would never touch it. It would get closer and closer. Let's get after it, huh? We'll get all this stuff. So find the y-intercept. Again, this is the number in front of the number with the exponent, which is kind of hard to see, but once we start like doing some problems here, because look, the x-intercept, or the y-intercept is like where it crosses the y-axis, and in each case it's like where x equals 0, what is y? So if you look at this one, if I was to put in 0 for x, it'd be 5 to the 0 power. What's anything to the 0 power? 1. So our y-intercept on this one would be at 0, 1. All right, now on this one, if we were to put in 0 for x, you'd have -2 times 4 to the 0 power. Now 4 to the 0 power is 1, so this would be -2 times 1, which is -2. So our y-intercept would be at -2. So again, here's the idea. It's always the number in front being multiplied by the number with the exponent. So the number with the exponent is the base. This is the number out in front being multiplied by the base. If you look at the you try problem, the number out in front is a 4. That would be your y-intercept. So our y-intercept is at 0, +4. Okay, if you can identify that, that's kind of the first step when you're graphing these, and then you could just pick some x values, put them in, and get your corresponding y values. So look here. F of x equals 2x. Remember, f of x is the same as y. So it's like y equals 2 to the x power. So our y-intercept would be, well, if we put in 0 for x, what would we get? 2 to the 0 is 1. So our y-intercept is 0, 1 on this one. You can go ahead and plot that, 0, 1. We're going to need some other numbers. So you could create a full table, or let's just pick some numbers to put in for x. And again, I always pick -0 or -2, -1, 0, 1, 2. We already know what it is for 0. But we're going to try these. Now some of these we could easily do in our head. If you did 2 to the first power, it's 2. 2 to the second power is 4. Now, if you were actually had to show the work for 2 to the -1st power, that would be 1 over 2 to the first power, which is 1/2 or 0.5. Your calculator would also tell you that. And if we were doing 2 to the -2nd power, that would be 1 over 2 to the 2nd power, which is 1 over 4, and 1/4 is 0.25. Now, you're not going to be able to tell the difference between 0.25 and 0.3 when we graph it. We're imperfect. But get the general spot for it. So -2 and 1/4 would be about there. -1 and 1/2 is about there. We have 0, 1. We have 1, 2, and 2, 4. So you'll you'll see it's got that swoop heading upward. So it's gonna approach the asymptote of the x-axis, and it'll swoop through these points and start heading up that direction. We did our best. Domain is your x values. It can be anything. This goes forever to the left, forever to the right. So we could say that the domain is x equals all real numbers. And you could just write a capital R with a line down it, kind of like a dollar sign with an R. And that would say all real numbers. There are other ways that you can write it when you get into Algebra 2. Use what's called interval notation. It's like negative infinity to positive infinity. That also shows all real numbers. The range is up and down. Now, this will go towards 0. It'll never touch 0. And then everything else is above that. So the way we would write that is we just say y is greater than 0. Right? It can't equal 0. It's going to be greater than 0. So for all of us, for domain, it's always going to be all real numbers for us. For the range, it's either going to be y is greater than 0 or y is less than 0. And again, that could change when you throw in some transformations later. Oh, wow. F of x equals 1/3 times 2 to the x. The y-intercept is the number in front of the base being multiplied. In this case, it's the 1/3. So our y-intercept is going to be at 1/3. So we'll say 0, 1/3. Which if we plot that, that's about 1/3. Wow, this is going to be pretty wild. We already know the domain's going to be all real numbers. So we can say x equals, and then the r with the line down it, all real numbers. And the y is going to be greater than 0. The only way it would be less than 0 is if the number in front, the y-intercept essentially, if that number was a negative number, that would reflect everything. We've got the hard work done. Now we have to pick some numbers to put in for x. We'll do the same numbers, -2, -1. We already know what it is for 0, 1, and 2. And you can do the math. You could do 2 to the first power is 2, and then 1/3 times 2 is 2/3. Or you could just put it in your calculator, and it'll give you the decimal, and the decimal is going to do just fine. So let's try 1/3 times 2 to the -2nd power. In my calc, it just tells me that's 0.083 repeating. So I'm just going to say 0.08. We're not going to be able to tell the difference with that 3 behind it. If I type in 2 to the -1st power instead, let's see if I can just change that. I get 0.16 repeating. 0.16. Okay. If we type into the first, 1/3 times 2 to the first is just going to be 0.6 repeating. And then once we do 1/3 times 2 to the second, 2 to the second is 4. 1/3 of 4 is 4/3, which is 1.3 repeating. These are real nasty decimals. We'll try our best. So we have -2 and 0.08. That's like barely off the line. We have -1.16. That's going to be a little bit higher. We have 0 and 0.3 repeating, or 1/3. 1.6 and 2, 1.3. So this is a little flatter, but it's still exponential growth. Not quite as steep as the last one. And again, you could choose any numbers you want to put in for x. If you want, you could put in 10. It might go off the graph, but you could do that. What else do we have? Ooh, example 5 and then a u-try problem? Sweet. Example 5, the number in front. In this case, the 3. That's our y-intercept. So our y-intercept is 0, 3. Boop. You could go ahead and plot that. 1, 2, 3. Domain for every problem is all real numbers. So we'll say x equals all real numbers, and then the range is above or below 0. The number in front is positive, so that means it's going to be greater than 0. All right, we're going to need some other numbers. So we're gonna pick our trusty -2, -1, 0 we already have, 1, and 2. You could do it in your calc, but we're pretty smart. Let's use our brains a little bit. Let's try to the first power. 2 to the first is 2, times 3 is 6. 2 to the second is 4, times 3 is 12. Okay, this is where it can get a little trickier. 3 times 2 to the -1st, you would drop the 2 underneath, so it'd be 3 over 2, which is 1.5. And then if we did to the -2nd, 3 times 2 to the -2nd would be 3 over 2 to the second. That's 3/4, which is 0.75. All right, we got our points. -2, 0.75 is about there. -1, 1.5, there-ish. We got 1, 6, and then 212 would go off of our thing, but we can kind of figure out the zone. And then we'll swoop. Whoa, yeah! Look at that, graphing is so much fun. There's one for you to try. Since I'm here, I'll just go over it with you. All right, our y-intercept is the number being multiplied out in front with the base. That's the 1/5. So we'll be at 0, 1/5, or 0.2 if that helps you. That's real tiny. That's about there. Now you could also scale your graph differently. I'm just going to keep it the same scale, go by ones. Domain is always all real numbers for these. Range is up and down, and the number in front is positive, so that means we're going to say y is greater than 0. We pick our other points, our -2, -1, 0 we know, 1, and 2. We could just put them into our calculator. Let's see, 1/5 times 2 to the -2nd power. It comes out to 0.05. All right, how about when we go to the -1st power? .1. Oh, wow. How about when we go to the 1st power? 0.4, that's cute. And to the 2nd power? 0.8. We'll try our best to graph these. -2.05. It's like just a frog's chin hair over the x-axis. I really stretched for that. -1, 0.1, 1.4, and then 2.8. Oh, that's that's like barely growing there. All right, that's it for day 1 of the notes. It was pretty tough though.